In this unit, we're going to start talking about lateral area and surface area. We're going to take everything that we learned about in the last unit where we were doing two-dimensional areas, and we're going to apply that now to three-dimensional shapes, because three-dimensional shapes are just made up of those two-dimensional shapes. So we're going to look first at our formulas. So the formula for lateral area is pH. P stands for perimeter of the base, so that's why we focused so much on knowing what the bases were when we were naming the shapes and doing faces, edges, and vertices. And then surface area is the lateral area plus the two bases, because the two bases are the ones that are parallel to each other and congruent. So B, capital B, stands for the area of the base, and the height is the height between the bases. So let's look at how this works. So every problem, I recommend that you do the same thing. First, find the base. So you read the question, you're like, okay, I'm looking for lateral area. This is a prism. I go to my formula chart and I say the lateral area of a prism is perimeter times the height, where you have to remember P is the perimeter of the base. So, and then the surface area means all of the surfaces. Lateral area means all of the surfaces except the two bases. The surface area is the lateral area plus the two bases. The reason I like for you to write the formulas first is because it helps you to recognize what you need to find first. So I'm going to color in the base. Now, when it is a rectangular prism, it does not matter which face you use as the base. I tend to like the one that it is sitting on, but it doesn't have to be that. And then the H is the distance between the two bases. So this piece up here is also the base. So there's this bottom base and this top base. And so the distance between those two is 4. Imagine you're taking that yellow rectangle, that is a rectangle, not a parallelogram. You're taking that rectangle and you're pushing it into Jell-O 4 meters. It would leave a space that has that hole. So now you can go in and you know you need the perimeter of the base. So perimeter means you add up all the sides. So 6 plus 2 plus 6 plus 2. So the perimeter is 16. And then the area of the base, well, that's a rectangle. So you step back for just a second. You go get the stuff you need. The area of a rectangle is base times height. The base of the rectangle is 6. The height of the rectangle is 2. And so the area of the base, big B, is 12. And then our H is 4. So we have all of the pieces. We have our P for perimeter, our H for height, and our B for the area of the base. So now all we have to do is go back in. The lateral area is equal to the perimeter, which was 16, times the height, which was 4. And you get that 16 times 4 is 64, and that would be meters squared. Then for your surface area, we already found pH, so we can just come over here and replace that. So you'd find your lateral area was 64, plus we're going to add the two bases, which would be this yellow shape and the one that's parallel to it on top. And they have an area of 12. We found that. So 2 times 12. So 64 plus 24 is 88, and that is meters squared. Now, it doesn't always have to be sitting on its base. To find out which one is the base, look for the ones that are congruent and parallel. And here's a hint: if you're ever using a prism, if you're ever doing a prism problem, if there's a shape other than a rectangle, that is what you want to use as your base. And then your height is the distance between those two. There's another base back here, but I'm just going to color one of them because that's all I need. Now, lateral area again. Lateral area is perimeter times the height. Surface area is the lateral area, perimeter times the height, plus the two bases. So perimeter and height, that's your 3 rectangles, and then your 2 bases are your triangles. And so you'd have 3 rectangles plus your 2 triangles. If you wanted to break this into pieces, you don't have to use the formulas. You can do a 25 by 10, a 25 by 16, and another 25 by 10 inch or a meter rectangle, and then add the 2 triangles. But I like to use the formulas. They're a little bit easier and they kind of give us a hint as to what we need. So the perimeter of this shape would be 10 plus 10 plus 16, so that's 36. The base, well, this is a triangle, so go back to your triangle section of your formula chart. That's the area of your triangle is the base of the triangle times the height of the triangle. So the base of the triangle is 16. The height of the triangle is, wait a minute, we don't know that. So let's take a break for a second. Let's go over and get that. Well, that line right there is called the altitude. It breaks the base of the triangle in half because this is isosceles. So we can do Pythagorean theorem to find that h. Now, there's a difference between the height of the prism and the height of the triangle. So you got to keep that straight. This is the h that we need for our three-dimensional measurements. So we're going to do h squared plus 8 squared is equal to 10 squared. Subtract 8 squared from both sides and you get h squared is equal to 36. Or h is equal to 6. So the height of my triangle is 6. That's what I use to get the area of my triangle. So the area of my triangle is 48. Now I have my big B, I have my P, and then I have the height of my prism, the distance between the two bases. So my lateral area is equal to the perimeter of the base, 36, times the distance between the bases, which is 25. 36 times 25, we do the math we can do, is 900, and that is meters squared. Surface area, it's your lateral area, so we already did that. We know it's 900 plus 2 times the area of your base. Well, your base, we found the area of our base was 48. So 900 plus 2 times 48 is 996 meters squared. Okay. In number 3, again, anytime you have a prism, if you have a shape other than a rectangle, that is your base. And I know it seems silly, but I highly recommend that you go ahead and color in the base because it really helps the shape pop out and helps, maybe you're having a hard time seeing it in 3 dimensions, and it gives you an idea of what you need. Lateral area, again, is the perimeter of the base times the height between the bases. Surface area is the lateral area plus the 2 area of the bases. So I've got to take a step back. I got to deal with this trapezoid for a minute. This side is 18. This side is 20. So the perimeter of my base would be 12 plus 18 plus 20 plus 23. That is 73. And the area of the base, you got to take a second to go find it, but it's the area of a trapezoid. It's 1/2 of base 1 plus base 2 times the height, and it's the height of, right now we're just focusing on the trapezoid, nothing else, so don't worry about anything other than what is yellow. So you type all that in on your calculator just like that, and you get that the area of the base is 246. Now we go over and we do our lateral area. Okay, lateral area is the perimeter of the base, 73, times the height, which is the distance between the bases. That's this one. I should have colored that in the beginning because it's the distance between the 2 trapezoids. That's the h you want to use for this part of the formula. 73 times 15 is 1,095, and that is square feet. Surface area, you take that lateral area, which is your 4 rectangles, so that's 1,095, and you add your 2 bases. The area of my base was 246, okay, and you do 1,095 plus 2 times 246, you get 1,587 feet squared. Okay, so with your prisms, you got to kind of separate it and think 2-dimensionally for a little bit and then think 3-dimensionally for a little bit. So let's look at this last one. Again, we need to find the area of our base because I look and I see lateral area. So your base is any shape that is not a rectangle. So that must be this hexagon. And then the distance between, there's another hexagon back here you can't see. So we need our lateral area. Lateral area is the perimeter times the height. So let's take a break for a second. Let's go over here and let's find our perimeter of our yellow shape. So our perimeter, this is a hexagon. It's a regular hexagon. It didn't state that, but we need to make that assumption. You'll be given that information. So perimeter would be 14 times 6 because there are 6 sides. So 14 times 6 is 84. And then the area of the base, you need to go find that on your formula chart. The area of the base, which is a hexagon, the regular hexagon, is 1/2 the apothem, which is the 12.12, times the perimeter, which we just found was 84. So the area of the base is 509.04. So we've got everything we need. Now we can come back over here and plug everything into our formula. So the lateral area is the perimeter, 84, times the height, which is the distance between the two bases, 18, and you get 1,512 square yards. Surface area, you take your perimeter, or you take your lateral area. Your lateral area is this, just to give you an idea of what we're looking at. Your lateral area is just the sides. It's everything except the bases, so it's always the rectangles. So your surface area would be all of your surfaces plus your two bases. So we take the 1512 we just got and we add 2 of the 509.04 bases. That gives us 2,530.08 yards squared. So that's how you do prisms. Now cylinders are nice. Anything that has a circle is nice because it automatically has a formula for it. So everything is based off of the area of a circle because this has that circle base on it. So the area of your circle is pi r squared. So we'll be using that. Your lateral area, if you look on your formula chart, your lateral area, which is basically your wrapper of your soup can, okay? So that's no circles. The circle is not included in that. The total surface area includes the circles. Just to give you an idea, when you have a word problem and you're being asked to paint part of it but not all of it, you want to break it into pieces like the net. Remember that the net looks something like that, 2 circles and a rectangle. So your lateral area is 2 times pi times r times h. And your total surface area is your lateral area, 2 times pi times r times h, plus 2 circles, 2 times pi r squared. That gets you the area of the circle. So the 2 pi r h gets you the area of the rectangle, and then you have pi r squared and pi r squared. So for your lateral area, when you see that you want a lateral area and you want it of the cylinder, that is 2 times pi times r times h. So you go and you get that information from your shape. So that's my radius and that's my height. Now I have everything that I need, so my lateral area is 2 times pi times the radius, which was 3, times the height, which is 6. Sometimes we want to leave that in terms of pi. You don't have to. You can type it straight in on your calculator, but just so you can see it, if you do 2 times 3 times 6, 2 times 3 is 6, and 6 times 6 is 36. So sometimes we could be asked to leave our answer in terms of pi, because pi has a lot of decimals, and if I don't want to use all the decimals, I could just leave it in terms of that. That's called exact. But then if I wanted approximate, I would actually hit 36 times pi on my calculator, and I would get 113.1. Now it's actually got a lot more decimals than that, but I rounded it. Your total area is your lateral area, 2 pi RH, plus 2 circles, right? We're adding both circles, so understand what the formula means. It's 2 circles, so you got your rectangle plus your 2 circles. So we already had that. I'm going to pull up this one so I don't have to write all the decimals and I don't have to worry about keeping them. Plus 2 times pi times the radius to the power of 2, or squared. So I'm going to keep it just so I can show you how it works. 2 times 3 squared. 3 squared is 9. 9 times 2 is 18 pi. Now, the pi's just act like a variable does if you want to leave it in terms of pi. 36 times 18 is 54. And then pi, just like if it was 36x plus 18x and you combine your like terms. And then approximately, if you type in 54 times pi on your calculator, you get 169.6. Now, I'm not going to ask you to leave your answers like that. I just want you to see that you can do it so you don't have to write them all down. But you can type it straight into your calculator and not have to worry about anything if you don't want to. All right, last one. The surface area of a soup can is 51.84. Okay, the surface area is 51.84. Okay, so surface area, and it's a cylinder. So the first thing you need to do is go write down the formula. 2 times pi times r times h plus 2 times pi times r squared. You want to write down the formula, and then you want to start plugging everything in. Let's finish the question. If the diameter of the can is 3 inches, remember diameter is all the way across, so the diameter is 3, that means the radius is 1.5. So what you do is you just substitute. Don't worry about what you're going to do with it. Just plug in everything and then start doing the math you know how to do. So 51.84 is equal to 2 times pi times r, I know, times h, I don't, plus 2 times pi times r, which was 1.5, squared. Now, there's nothing I can do on the left, so I'm going to keep that 51.84 equals, well, I can multiply 2 times pi times 1.5. That is 9.425. Just keep several decimal places. And then plus, and I can type in 2 times pi times 1.5 squared on my calculator, and I can get 14.14. Now, you cannot type in 2 times pi times 1.5 plus 2 times pi times 1.5 squared. You can't do that because of that h. They're not like terms. See, this has an h and this doesn't, so you can't type those in together. So you have to type this one in, and then you have to type this one in. Well, now we're just doing a regular algebra problem. I need to solve for the height. So I'm going to subtract 14.14 from both sides. That gives me 37.7 is equal to 9.425h. Then divide both sides by 9.425. And that gives you that the height is 4. So the height of the can would be 4 inches tall. So cylinders are nice because they have their formulas. Just recognize what each of the formulas represent. The lateral area is the rectangle or the wrapper around the soup can, and the total surface area includes both the top and the bottom of the can also. So that would be how much metal you need to make the entire can. So be sure that you know how to use these formulas because they're very important to know how to do.